Today we're looking at Unit 2's multiplication test review. We're going to go through each different learning goal, each topic that we covered in this unit, and we're going to look at examples of what questions you may see similar to the test. So in the very first concept that we covered, we looked at estimation. And I want to remind you that the number one thing to remember with estimation is that all work must be done, all estimation must be done in the work. Meaning, if you do the work and you get an answer, you're not rounding the answer. That's going to defeat the whole purpose for estimation. So in this case, the strategy that we'll use, we read the question. 5th grade students at MJE sold candy bars to raise money. They sold 57 boxes of candy bars. Each box contained 223 candy bars. What is the best estimate for the total number of candy bars? So in our strategy, the first step is we identify the two numbers, or however many numbers it is. In this case, we're trying to find the best estimate for a total. So the math that's happening is 223 times 57. But we want it estimated, meaning I'm not going to sit here and multiply 223 times 57. I'm going to do the estimation first. In step 2, once we identify the numbers, we're going to come up with all the possibilities those numbers could be estimated to. So if a number goes to the hundreds, I'm going to think about what is the closest hundred. In this case, for 223, it would be 200, because the 2 would leave this 2 alone. And I'm also going to think about the tens place as well. So 223 to the tens place would be 220. With 57, the only thing that remotely makes sense is rounding 57 to 60. Once you've come up with all the possibilities for those numbers, then step 2, you need to come up with all the combinations. So you would multiply both 200 times 60 and 220 times 60. And when you go to make these combinations, if you get to one that you can't do in your head mentally, then 9 times out of 10, that's not going to be your answer, because the whole purpose of estimation is to make it mental math. So 200 times 60 we can easily do, because that's the basic fact of 2 times 6, which is 12. And then there should be 3 zeros as placeholders. 220 times 60, a lot of us can't do that in our head. But if you wanted to, just to double check, you could jot down, we already decided that 200 times 60 was 12,000. So since that's the same number, it'd be the same answer minus a 0. 20 times 60 would be 1,200. And I can put that together, and I get 13,200. In step 3, you're going to compare these combinations that you came up with to your answer choices. And if you found all the possible combinations, then one of your answers should be an answer choice. There shouldn't be any guesses or any closeness. It should be an exact match. And in this case, it was 12,000. Okay. The second concept that we looked at in this unit was multiplying whole numbers, 3-digit by 2-digit numbers. In this question we're going to look at, it says Ashlyn counts 14 boxes of pencils and 10 boxes of markers for Miss Smith. There are 130 pencils in each box and 25 markers in each box. How many pencils and markers does Miss Smith have total? As you start to see, our word problems are getting more and more in depth with more steps to them. So we're going to go back to our strategy of our think, know, wonder chart to organize our data. We read the question. So Ashlyn counts 14 boxes of pencils and 10 boxes of markers. We stop at the period. In this question, I know that she has 14 boxes of pencils and that she has 10 boxes of markers. right now I'm not really thinking anything or wondering anything new. I'm going to continue to the next sentence. There are 130 pencils in each box and 25 markers in each box. So I'm going to note that I know 130 pencils per box, 25 markers per box. Now I'm starting to wonder some things. How many pencils in all? Okay, when I wonder about that, I'm thinking I have two numbers, and these numbers each occur every time. I'm thinking I'm going to multiply those numbers together to figure out the answer to this question. I'm also wondering how many markers are in each box. I'm sorry, how many markers total? I know how many are in each box. Total. So I'm going to look at what I know. I know that there are 10 boxes and 25 in each box. I'm going to also think that I need to multiply those together. And I'm going to begin, I'm going to look at the final question, or the final piece to my question, which is how many pencils and markers does Miss Smith have in total? And I'm going to begin to build that order of operations from that very first unit we did back at the beginning of the year. Okay? I know that this final question is asking me to put all of my pencils and, meaning adding, combining all of my markers together to give me a total. So now I'm going to go back in and I'm going to look at what I know over here. How many pencils do I have? Well, it doesn't just come out and tell me I have 150 pencils. Instead, it tells me two different pieces of information, meaning I need to do something to figure that out. So I'm going to isolate it, put it in parentheses. I have 14 boxes and each one has 130 pencils. So that means I'm going to have to do 14 times 130, because the first box has 130. The second box has 130, and so on. That continued repeated addition means this is multiplication. Then I'm going to look at how many markers. Again, it doesn't give me an exact number. It gives me two different numbers. It tells me that there's 10 boxes, and each box has 25. This is going to give me my total. Now I have a roadmap for the different steps that I need to answer this final problem. And I see that after I do these two pieces of math, I'm still not done because the final thing I need to do is add. So this keeps everything in check so that I don't miss any steps. So looking at 10 times 25, I skipped over here for a reason because this is mental. I can do 10 times 25 in my head. Because really it's 1 times 25, which is 25, and then I need that 0 as a placeholder. This number over here, 14 times 130, this is what goes back to our 3-digit times 2-digit multiplication. So I'm going to do this one on a piece of notebook paper using our 3 different strategies, depending on which one you chose. If you chose the area model, remember that we write our numbers in expanded form, 14 times 130, okay? So I would have 130. Because this is a 0, I don't need to do this set of boxes because 0 times anything is 0. So that's just extra work that's not needed. So then I have 10 and I have 4. And if you remember where each one meets together, so everything under the 100 is multiplying with 100. Everything under the 30 is multiplying by 30. Everything beside the 10 multiplies by 10. And everything beside the 4 multiplies by 4. So now it's just basic facts. I know that I'm going to need 3 zeros as placeholders, and 1 times 1 is 1. In this problem, I need 2 zeros for placeholders. 1 times 3 is 3. Down here, I need 2 zeros. 1 times 4 is 4. And then I need 1 zero. And 4 times 3 is 12. I take these numbers. I'm going to go adding out to the side. 1,000 plus 13 or plus 300 is 1,300, or 1,300. And 400 plus 120 is 520, for a total of 1,820. Now that was a lot of work. And if you had not found this roadmap, you would think you were done, and you would look for that 1,820 number. And chances are it's going to be one of your answer choices. You have to know that you're not done. You need to combine that 1,820 with 250. And when you do, you would get 50 plus 20 is 70, and 800 plus 200 is 1,000, and when I carry that 1, I'd get 2,070. Okay? Now, for the record, if you did partial products, 130 times 14. If you're at this level, then you should have seen 10 times any number is that number with that extra 0 as a placeholder. And then you should move on. You would have had 100 times 4 is 400. 100 times 30 is 120. And of course, 4 times 0 is 0. You would have ended up with the same similar numbers, and the same answer would have also resulted. You would have had 1,820. If you chose to do the standard algorithm, of course 4 times 0 is 0. 4 times 3 is 12. We would have carried a 1. 4 times 1 is 1, plus 1 is 5. I'm going to mark it out so I don't reuse it. I need a 0 as a placeholder before I even start, because I'm starting in the tens place. Then I start 1 times 0 is another 0. 1 times 3 is 3, and 1 times 1 is 1. Again, I end up with 1,820.